Hello all you cool cats and kittens, this is Miss Bartels teaching today's lesson on vertex form. Let's get started. So a quadratic function has the form y is equal to x squared. This is known as the parent function of a quadratic. So I'm going to explain a quick way for you to remember why it's called the parent function. Think about your parents. They're kind of like the originals, just like this quadratic function. The parent function, y is equal to x squared, is the original function. And then kind of every generation like us, we start to create our own unique characteristics and kind of features, just like a quadratic function. You'll start to see things added on, subtracted, multiplied, and all that. So that's kind of just my little way of remembering why it's called a parent function. So let's get started and graph this parent function. So I'm going to choose the table to go from 3 to -3. So this might be a little reminder of last semester. So 3, 2, 1, 0, 1, 2, 3, and these are going to be our negatives. The reason I chose those numbers is usually you would choose those numbers in a parent function. Later on when we graph, I will show you how to decide what x values to choose. So now we plug it in. Plug each x value into your x. So I'm going to get my zoom in here so I can write better. So our first one's going to be 3 squared. That gives us 9. Next one's going to be 2 squared. That's going to be 4. Then we have 1 squared. That's going to be 1. 0 squared. And we get 0. -1 squared. And we get 1. -2 squared. We get 4. And -3 squared. We get 9. So before I continue, I just want to quickly explain why I put the parentheses there. And I highly encourage you to do the same, because if we go over to our calculator and I type in -3 squared, you get 9. But what if I didn't use the parenthesis? What if I just typed in -3 squared like that? Well, we get -9. And that's because the calculator isn't reading it as -3 squared, it's reading it as -1 times 3 squared. So that's going to give you an incorrect answer. So make sure when you type it in your calculator to use those parentheses when you're working on the Go formative. That will ensure you the correct answer. Okay, back to work. Now if you look at this, you're going to see that we see some symmetry up here. So our 9 matches our 9, 4 matches our 4, 1 matches our 1, and 0, 0 is directly in the middle. Let's graph that. We get 0, 0, 1, 1, 2, 4, and 3, 9. And then it's just going to kind of mirror on the other side. -1, 1, -2, 4, and -3, 9. There's our U-shaped parabola. Okay. Now Monday and Tuesday, so yesterday, you were working on all of the bottom 9 questions. If you have not watched Monday's video, I highly encourage you to go back to Monday and watch the video before continuing this, because that's where you learned about all of these. So let's go through them. Our axis of symmetry is where the graph is split right down the middle, and it looks like it's split right here at our x is equal to 0 line. So our axis of symmetry is x is equal to 0. Our vertex is the point right at the bottom. It's kind of where everything folds. It's also shown right here. So our vertex is 0, 0. Y-intercept is where it crosses our y-axis, which is this line. So again, that's going to be 0, 0. Our zeros, remember, those are also known as our x-intercepts. So it looks like it crosses our x-axis right at 0, 0 as well. That vertex is the minimum point, so we have a minimum. in quadratics, you will start to notice our domain is always all real numbers. So this is going to keep extending, and this will keep extending to infinity. And that's where we get the all real numbers from, because it covers all of these x values to infinity as well. Our range. Let's think of the lowest point since we have a minimum. Our lowest point is 0. That means y has to be greater than 0. So to explain, here's our 0, here's where y is 0, and y is always greater, so it's everything up here. So that's where you get y is greater than 0. So as x goes to negative infinity, so as we go to negative infinity over here, our arrow is pointing up, and up means positive infinity. As x's go to positive infinity, so this way, our arrow is still pointing up, so that's also going to be positive infinity. Now when we're working with quadratics, those should always match, because that's kind of what a quadratic function is. The arrows are always pointing in the same direction, and it's a U-shaped graph. So, on to the next page. Now that you heard me say it a few times, the graph of a quadratic function is U-shaped, and we call that a parabola. Okay, so we call a U-shaped graph a parabola. So again, when you're drawing it, try your best to make it that U-shaped. I don't want to see any sharp cut V's, okay, because it's specifically a U-shaped graph. Okay, finally moving on to vertex form. So a quadratic function shown in this form, y is equal to a, x minus h squared plus k, is called vertex form of the quadratic equation. And I'll explain real quick why it's called that. We have an h and we have a k here. Those are a little bit unfamiliar to us. Well, if I put it in a coordinate pair, h comma k, this is actually our vertex. So the reason it is called vertex form is because it gives us our vertex right in the formula, right in the equation. So let's explain that a little more. What happens if we were to have the vertex of 6, 2? Well, it would look something like this. X minus 6 squared plus k. Oh, not plus k, we put 2 there now. So it would look something like this. I want you to notice it says minus 6, but our vertex is a positive 6. So I always say it's opposite of what you see in the parenthesis, or make sure you take the h value. So I would stick to what's opposite in the parentheses. So if you see minus 6, go ahead and write a positive 6. Okay, we're going to go to desmos.com now, and we're going to kind of see how everything is affected. The h, the a, the k, all of that, we're going to see how it changes in the graph. So I'm going to switch on over to Desmos. We're going to work with our a first. First things first, let's see what happens when I move the a to bigger numbers. So as the a value gets larger, the graph is compressing. And as the a value gets smaller, the graph is stretching. So let's first take note on that. So it stretches and it compresses. When a is kind of greater than 1, and it compresses, sorry, this is supposed to say smaller. So it stretches when a is smaller. So when a is a decimal, or the smaller a is, it stretches, and it compresses when a is greater than 1. And the word compress, I kind of always say skinnier. It gets skinnier. And then when it stretches, I say wider. It gets wider. Okay? So the graph will stretch as a gets bigger and compress as a gets smaller. Moving on over. Let's keep working with a. What happens when a goes negative? So right now it's opening up. And the second I switch to negative, it opens down. And as the negative numbers get larger, it starts to compress again. And as the negative numbers get closer to 0, it starts to widen. Okay. So I actually kind of want to reword this because it's not when a is smaller than 1. We're going to say when bigger number and compresses when smaller number, if that makes sense. Okay, just wanted to reword that because negatives, as the negative number gets larger, it still compresses. Okay. And then we're going to write over to the side, it opens up and opens down. Okay. Let's see how the h is affected. When I move the h, it's moving the graph left and right. Okay? So we're going to call that a horizontal shift, because it moves along that horizon. Okay. So if that moved it left and right, what do you think happens when you move k? It's moving it up and down. So we're going to call that our vertical shift. Okay, so that was kind of exploring it. Now below, I'm going to bullet point what actually happens. And I highly recommend you write this down on a piece of paper because it will kind of help you work on a few problems on the Go Formative as well. So, moving down, our A value. Let's go in the color green. So our A value, if it is positive, it will open up. If it is negative, it will open down. Okay, on to H. When it is negative, ooh, that color, I'm sorry, I'm changing it. When it, let's start with positive. When it is positive, it will shift left. And when it is negative, it will shift right. And I want to explain that one a little bit further. So when, let's get pink in there. So when H is positive, so if I use 6, 2 again, H is positive there, right? Well, in the formula, x minus H, it's going to say x minus 6 squared plus 2. And since it says minus 6, it's moving it left 6. So that's why, again, everything in the parentheses is opposite of what you think. Now, if we have a negative 6, 2, so now H is negative, it's going to say x minus negative 6 squared plus 2. And we all know a double negative turns to a positive. So it's going to say x plus 6 squared plus 2. So now, since it says plus 6, we are moving right 6. So again, whatever is in the parentheses is opposite of what you think. Last but not least, k. So if k is positive, we're going up. And if k is negative, we're going down. Okay, pause the video here if you want to write all this down. Trust me, it will help you in the future. Moving on to our first example. We are going to graph y is equal to x plus 3 squared. So I'm going to zoom into this formula. And we're going to write the vertex form above it. Y is equal to ax minus h squared plus k. So again, let's find our vertex, because that will be most helpful to graph. It's minus h, so again, it's opposite of what you see here. If we see a positive 3, we write negative 3. Do we see a k at the end here? I don't. So that means it's technically same plus 0. So our k value is 0. So we found our vertex, and this is how you choose what x values to write. Your vertex goes smack dab in the middle, and then count 3 in both directions. So negative 3, negative 4, negative 5, negative 6, and then negative 3, negative 2, negative 1, and 0. And that should give you the perfect U-shaped graph. So now let's plug all of that in. I'm going to go over to our calculator and show you how I quickly do that. So our formula is x plus 3 squared. So I'm going to write 0 plus 3 squared for the first one, and we get 9. So I'm just plugging this into our x, the x value into our x up here. Now we have to plug negative 1 in. So I just kind of delete what I have and change it to a negative 1. We get 4. Change it to a negative 2. We get 1. Change it to a negative 4. We get 1. Change it to a negative 5. Oh, wrong place. We get 4. And change it to a negative 6. And you get 9. So, you know you filled out your table correctly if you start to see this symmetry right here. The 9 matches 9, 4 matches 4, and 1 matches 1. If you did not see that symmetry, try to re-plug in your values to catch where you may have messed up, or double check your vertex. So those are the two places for errors. Let's graph it. So we get 0, 9, negative 1, 4, why isn't it writing? There we go. Negative 2, 1, negative 3, 0, negative 4, 1, negative 5, 4, negative 6, 9. There is our parabola. Oops. Okay, let's fill out the bottom. Axis of symmetry is happening right here, which is x is equal to negative 3. Vertex is happening right here, and we found it up here. So that is our negative 3, 0. Y-intercept, it's crossing, let's get a different color in it right here. So that is 0, 9. Our x-intercept is actually our vertex. So that's negative 3, 0. This has a minimum. Domain is our x values, and that is all real numbers. Our range, well, it's at y is 0, because range is our y value. So y just has to be greater than or equal to 0 again. And then both of our arrows are pointing up, so whether x goes to negative infinity, we're going to positive, and as x goes to positive infinity, we're still going to positive. Okay, so that's example number 2. moving on to the next page. So for this one, I want you to give it a try on your own. So I'm going to get you started with the table in case you need a little oomph. Our vertex is again opposite of what you see, so we're going to write 1, and it's going to be our 4, H comma K. So again, that goes right in the middle, 1, 4. And I want you to count up by 3 and down by 3. So 1, 2, 3, 4, 0, -1, -2. Go ahead and fill out the rest of this table and then graph it to the right. Pause the video here to do that. Okay, so you should have gotten something like this when you were to graph it. If you didn't, go ahead and fix it now. Otherwise, we're going to go ahead and try the bottom. So pause the video here to give the following 9 boxes a try. Okay, let's go through it. For the axis of symmetry, did we get x is equal to 1? Because it's right here at our x is equal to 1 line. Our vertex we already found, so that you should have gotten 1, 4. For the y-intercept, 0, 3. For our zeros, we get -1, 0, and we get 3, 0. Oops. And I just noticed there's a little bit of an error on the graph. Right here is 3, 0. I had to shift all of it over a little bit. So I was even a little off on that. Okay. There's my messy version of the graph. Sorry about that. Okay, minimum or maximum. You should have found it to have a maximum because our vertex is at the maximum point. Domain, all real numbers. Range, y just has to be less than 4. So here is our y where y is 4. And everything just has to be less than it. So that it should be lower. It should be below it. As x goes to negative infinity, the graph is going down, which is negative infinity. As x goes to positive infinity, the graph is still going down, which is negative infinity. Let's try one more on your own. Go ahead and pause the video here and fill out the following page. Okay, let's see how we did. Our graph should have turned out something like this. If not, go ahead and pause the video and try to find your mistake and go ahead and correct it. Okay, let's move down. Let's see how we did on the following. Our axis of symmetry is going to be y is equal to -3. X is equal to -3. Our vertex is going to be -3, -2, and that's what we found right up here. Our y-intercept, now you're not able to see it from the graph because the graph is off the page, but you can see it from right up here. It's going to intersect right at 0, 16. Our zeros, we have 2 of them at -2, 0 and at -4, 0. Our graph has a minimum. The domain of the graph is, as always in quadratics, all real numbers. The range of it is going to be y has to be greater than -2. As we go to negative infinity, graph is going up to positive, and as we go to positive infinity, graph is still going up to positive infinity. Okay, I hope that was enough examples for you on this to help guide you through the Go Formative tomorrow. But we have one more thing we need to go over. And that's, what if we are not given a graph? How do we figure out all the information? Well, first thing, we know how to figure out the vertex. So let's work on column A together. Our vertex is opposite of what we see, so we're going to have -6, comma, -3, which is our k. Now, if I go to our previous page, what can we connect about the vertex and the axis of symmetry? Well, if you notice, our x value in our vertex is the same as the axis of symmetry. So that's what we can use. Going back, we're going to take our x value here to help us with our axis of symmetry. So that's going to be where x is equal to -6. We're going to talk about how everything differs from the parent function. So we're just going to talk about the shifts, what's happening. So this is where writing down this bottom half is going to come in handy. So we're going to use all of this information right here to help us with that. So the 4, what is the 4 going to do? What is that a value going to do? Let's zoom out. Our a value of 4 is going to compress it. So it's going to compress the graph. So I'm going to write our a in parentheses here, and that's going to compress the graph. Now our h says +6. So right up here it says +6. So again, remember opposite. So if it says +6, we're moving left 6 units. And lastly, our k. Our k says -3, so we're going down 3 units. Okay? So that is how we decide what the a, the h, and the k differs from this parent function right up here. So go ahead and pause it and try to fill out the column for b. Let's go through it. So our vertex is going to be +2, 10. So opposite of what you see here, and then 10. Axis of symmetry, we take that 2. So we get x is equal to 2. Now let's talk about how it differs. I'm going to zoom out. Our a, we have a negative. That negative is just telling us it opens down. Our k, that tells us we're going right 2 because it says -2. And the h tells us we're going up 10. I'm going to say units. I'm going to go write units next to the 2 as well. Okay, last one. I'm going to get you started. But we have, if we think of our vertex form, y is equal to a x minus h squared plus k. This is technically written in the same way, but our a is that 1/8. Our x just means there's nothing there, so it's x minus 0 squared plus 1. So that's exactly what it's saying. So if you ever see x alone, it means that it's x minus 0. So that means our vertex is going to be 0, 1. Again, I'm going to use this. Our axis of symmetry is going to be x is equal to 0. Let's talk about how everything changes. So our a value, it's going to stretch the graph because it's a fraction. Our h value changes nothing. Because it's 0, so it's not moving right or left. And our k value, and what is our k? +1, so we're going up 1 unit. Okay. And that is the end of vertex form notes. So these were pretty long notes, so thanks for bearing with me. Good luck on the Go Formative tomorrow, and if you have any questions regarding Vertex Form, don't be afraid to reach out to any of your teachers.